All right, welcome to Lab 5 on Le Chatelier's Principle. We're going to be looking at a reaction and seeing how to apply Le Chatelier's Principle to this equilibrium reaction. All right, so to begin with, we should define what equilibrium is. Equilibrium is when the forward rate of the reaction is equal to the reverse rate of the reaction, and therefore, as a result of this, the products in terms of concentration and reactants, the concentration of these products and reactants are not changing. They are not equal to one another, but the concentrations itself of the product and the reactants are not changing. So, Le Chatelier's principle states that you can shift the equilibrium of a reaction by changing one of three things. You can change the concentration of the products or the reactants, either adding more products or reactants, or removing products or reactants. You can change the pressure by changing the volume. You can either increase the volume and decrease the pressure, or you can decrease the volume and increase the pressure. They are inversely related to one another. However, this only works with gases, and since we are not working with gases but with aqueous solutions in this lab, we won't be doing number 2, changing the pressure. Okay? Number 3, we can change the temperature of the reaction, because if it's an exo or endothermic reaction, heat is either a product or a reactant, and so by adding more heat or removing heat, you can again shift the equilibrium of the reaction. Okay. Let's look at some examples of how we might apply this principle. Example 1, we would like to shift the reaction to the right. In this particular case, you can do a couple of things. You can add reactants. Okay, you can add A or B or both, and it'll shift the reaction to the right. Or you can remove the products, either C as the product you can remove, or you can remove heat, because in this case, heat is a product in this reaction. Removing heat really just means to lower the temperature. In this particular case, because heat is a product, that means that this reaction is exothermic, meaning delta H is negative. Okay. Example number 2, a shift to the left. Again, the same reaction, but we would like to shift it in the other direction to the left. Okay. In this case, we can either remove the reactants, either remove A or remove B. Or we can add the products. In this case, we can add C or add heat. Add heat just means raising the temperature. Okay. Example number 3. You want to increase the concentration of B. B is here. Okay. Notice in this reaction, I have heat on the left-hand side. Heat on the left-hand side is a reactant. In this case, because heat is here, this signifies an endothermic reaction where delta H is positive. Okay, so I would like to increase B. The way to increase B is I can remove some of the reactants. So I can remove some of the heat by lowering the temperature. I can remove some of the A, or I could add some more product. In this case, I could add more C. Okay, last example, example number 4. Let's say I would like to increase D. Now, in terms of D, D is a product, so I can add more heat, meaning raising the temperature. I can add A or B, or I could remove some product, which is C. Okay? These kinds of examples are very helpful to you. I would look at your pre-lab, and when you're looking at your pre-lab, you might want to look at some of those questions and see how to do it in terms of question 3 and question 4. Okay? It is very important when you're doing question 3 and 4 that you write heat either as a reactant or a product to help you figure out what will happen if you increase the temperature or you lower the temperature. So what will we be doing in lab today? Okay. Today's reaction is we will take some solid COCl2, which is purple, and we're going to add it to water. Right away you will see that the aqueous solution is a little pink in color, more like a dark pink, but a pink in color. The reason is because in the solution, you don't have CO2+. Neither do you have COCl. What you really have because you have an overwhelming amount of water, you're adding the cobalt chloride to 25 mils of water, is that you will form cobalt with 6 waters attached. It overall has a 2+ charge because water is neutral and cobalt is 2+. Okay. This complex here, we'll call the water complex, is pink. So this solution will be pink because of the overwhelming amount of water. Is there some Cl there? Of course, because you're adding CoCl2, but not enough to knock off the waters because there is way more water than there is Cl- in solution. Okay. Then you're going to add HCl. When you add HCl, what you're doing is you're adding really Cl-, right? You're adding H+ as well, but H+ has no effect on this reaction. You're really just adding Cl-. You're adding so many Cl-, you're starting to knock off the water on the cobalt water complex, and you're starting to form CoCl4 2-. CoCl4 2- is blue. So at an equilibrium situation where you have some pink, some blue, what color will you see? You will see a violet color, because when you mix pink and blue, you will get this purple violet color. If you continue to add more HCl, again, you're adding more and more Cl-. Eventually, all of the pink will react and form CoCl4, 100% of this, and this solution is blue. Okay, so really the reaction we are doing today is we're going to take this water complex, add Cl-, and it forms this chloride complex plus water. Okay, think about it now. If I add more Cl, I can shift the reaction to the right. If I remove Cl, I can shift it to the left. If I add water, I can shift it to the left. Okay, see some of the things that's possible in terms of this reaction. In addition, okay, this reaction has a delta H, okay, of 50 kilojoules. Okay, because it is positive, we should write heat as a reactant, because it is endothermic. Okay. All right, so based on this, we know what we're going to be doing today. Okay. The first thing we need to do is figure out how much CoCl2 I need to weigh out. Okay. And the instructions ask you to make a 25 ml solution at a concentration of 0.1 molar. And so the way to do that is to take the 25 mils and convert it to liters. Then use the concentration of your desired solution to convert to moles. And then to convert from moles of Cl2 to grams of Cl2, we just use the molar mass. We need a grams here. Okay? That will get you 0.59 grams of cobalt chloride. Please write this down as number 1 on your data sheet. Okay? You should have a data sheet that looks like this. Okay? So on your data and observations for number 1, you're going to write this calculation. Okay? Then you should continue to keep the data sheet, because I'm going to make the solution and we're going to do all these test tubes and we're going to write down what happens before and after. Okay? So please make sure you have that out with you as you continue to watch this video. If you don't have it, please pause the video and get it out. Okay? All right. Okay, looks good. So I'm going to take the CoCl2 and add it to my beaker. Okay. And to that I'm going to add 25 mils of water. Okay. And I'm going to get that stirring. Okay. And notice that the solution is a pink color. Okay. And it is pink because what is predominantly in solution is your cobalt water complex, okay, which is pink in color. Okay. To it, I'm going to start adding concentrated HCl. And as I add HCl, notice that it's going to shift the reaction to the right, forming the cobalt chloride complex. And I will need to add quite a bit of HCl, so I have an extra large pipette to do exactly that. Okay, notice that the reaction has started to turn a purple color. Remember, when it is purple like this, what is in solution, okay, is really some cobalt water complex and some cobalt chloride complex. So when it's purple like this, you have some of this and some of this. Okay, I'm going to continue to add. Okay, and notice that the reaction has turned dark blue. Okay, again, it is blue because I have added so much Cl minus by adding HCl that I have formed the CoCl4 2 minus complex completely 100% in this beaker. Okay, I'm going to stop the stirring and I'm going to prepare test tube number 1. Okay, so I'm going to transfer my solution into a test tube, okay, and do my first experiment. Okay, I'm going to move this aside so that you can really see what's going on when I do each of these situations. And I'll put the test tube here so you can hopefully see it okay. Okay. So, in the instructions, which I need to find, it says for the first solution that I should put it in ice water. Okay, so let's do that. Get some ice water. Okay, I'm gonna just go ahead and dunk it in my ice water. Okay, remember it was blue when we started, so in that first box on your data table, the color before should be blue. Okay, and we're just going to cool it down in my ice water. Could take a while. Meanwhile, I will prepare test tube number 2. So you can see that after I've left it in the ice water for a little bit, it has turned to a light purple color. Okay, and just as a comparison, this was the blue before, this is the color now. Okay, it's turned into a light violet color. Okay, why has it turned into a light violet color? It is because we had we had 100% of this, and we are cooling it, meaning we're removing the heat. Okay, removing the heat, removing the reactant shifts the reaction to the left. So now it's violet in color because you have some of this and some of this in your solution. So in that first box for the color before, you're gonna write blue, and then the color after, you're gonna write purple or violet. The explanation of the stress is that you have removed heat by cooling it, and heat is a reactant, therefore you're shifting the reaction to the left. Okay. Then it says for the same test tube number 1, we're going to put it in boiling water. Okay, so let's do that. Okay. I have some boiling water here. Okay, and I'm going to take it from my ice cold water and put it in my boiling water. Okay, immediately you should see a color change. It is changing to a, well, it's hot. Okay, it is changing to a blue, very, very blue color. In fact, more blue than what it was when it started. Let me give you as a comparison. This is what we started with. This is the color it is now. Okay, it is much more blue than it was before. Okay. The reason that it turns blue is, again, let's consider our reaction here, which now is being blocked by the boiling water. Okay, let's consider our reaction. It was blue. Sorry, it was purple, right? We stuck it in the ice water. So the color before was purple. Okay, so there was some of this and some of this in solution. And then we heated it. When we heated it, we're adding heat. Adding heat as a reactant shifts it to the right, making it completely blue. Okay, and again, now it looks completely blue. Very, very blue. All right, so I'm going to remove the boiling water. We're going to move on to test tube number 2. Okay. Test tube number 2, again, we're going to take it. It is blue, so the color before is blue. And what we're going to do is we're going to add a little bit of water. Okay. And I'm going to give it a nice little stir. Sorry about that. Okay, I need to add a little bit more water. Okay, again, I have achieved a violet color. Okay, so it was blue and now it's violet. Okay, why is this the case? Okay, it was blue, 100% blue, so it was 100% this compound. I'm adding water, which is a reactant, and it's going to shift it to the left. So now in this purple solution, I have some of this and some of this. Okay, so for test tube number 2, the color before was blue. The color after adding water is violet. The reason or the explanation is I've added water, which is a product, shifting the reaction to the left. Okay. Then it says to take this test tube that's violet and add a couple drops of HCl. So I'm going to do that. This is my test tube. Okay. I'm going to add a couple drops of HCl. Okay. Notice the color is now blue. Okay. What is the reason? The reason behind this, again, we should consider what is going on in the test tube. It was purple before, that's the color before. So there was some of this and some of this. I've added HCl, which is basically adding Cl minus. So it shifts it to the right to form more CoCl2. Test tube 3 asks us to do that, to do the same thing. I'm going to get some of my solution, add it to my test tube. This is test tube number 3. Okay. And it says to add water until it turns pink. So let's do that. Let's add water. Okay, I've reached purple, which is half-half. Add a little bit more. Not quite there yet, still purple. Okay, that looks pretty pink to me. Okay. Okay. Why can I add water until it is pink? So this is test tube number 3. Before it was blue, I added water until it is pink. I have basically added so much water, as water is the product, I've added so much water that I've shifted the equilibrium to almost completely this compound in solution. That's why it's pink, because it's almost completely this compound in solution. Okay, so that's the first thing you should write down for test tube number 3. Okay, I've added water. Before it was blue, now it is pink. Okay, and the reason is because adding water as the product shifts the equilibrium to the left. Okay, then it says I'm going to take some calcium chloride and I'm going to add that to the test tube. So I'm going to get out some calcium chloride. Okay, calcium chloride is a white ball or pellet, looks like this. Okay, I'm going to go ahead and add it to my pink test tube. Trying not to spill all of it. All right. And it says to note down what it looks like when the calcium chloride has settled to the bottom. Okay. Notice that where the calcium chloride is a blue, bright blue color. So you would assume that at the bottom of the test tube is predominantly your cobalt chloride complex, which you are correct. Okay. Why is this? Let's again go back to our reaction. Pink solution, predominantly this complex, the water complex. Okay. We've added CaCl2 or calcium chloride. That's adding Cl minus. So really adding Cl minus, same thing like when we added Cl minus when we added HCl, it's going to shift it to the right and form CoCl4, 2 minus, which is blue. That's why when you're looking at this test tube here, the bottom where the calcium chloride is blue. Okay. All right, very good. So for test tube number 3, in that second box, you're going to write it was pink. Now it's blue, and the reason is because adding calcium chloride shifts the reaction to the right because you are adding chloride as a reactant. All right, test tube number 4, I'm going to add a couple drops of water. Before I do that, I actually have to make test tube number 4. Okay, test tube number 4. I'm going to add a little bit of my water. And again, we expect the same thing to happen. Adding water is going to make it pink if I add enough. Okay. Actually, I'm going to add it until it turns purple. Okay. I'm not going to follow the instructions. Okay. Notice it is the purple color. Okay. Now, the reason why it turns blue to purple is because adding water as a product shifts the reaction to the left. Okay, so now you have some of the cobalt water complex and some of the cobalt chloride complex in this test tube. So that's the first thing you should write down. In that test tube number 4, you should say before it was blue, after it is violet. Again, you've added water, which is a product shifting the reaction to the left. Okay. Now we're going to add some silver nitrate. Okay. So I'm going to grab my silver nitrate. I'm going to go ahead and add that to my test tube. Okay. And you immediately notice a precipitate forming, right? Okay. I'm just going to shake it so that you can see. And see, you can see a precipitate forming at the bottom there. Let the camera focus here. The precipitate at the bottom is silver chloride, AgCl. Okay. So what has happened as you add the silver nitrate is the Ag plus cation is grabbing the Cl minus and forming a precipitate. When it forms a precipitate, what you're actually doing is removing the Cl from the solution because it's now a precipitate, right? So really when you're adding silver nitrate, silver Ag plus grabs the Cl to form AgCl. It forms a precipitate, so you're basically removing Cl from the solution. If you're removing a reactant, you're shifting the equilibrium to the left, okay? So before it was some of this, that's why it was purple before. And as you remove Cl, you're shifting it to the left until it's forming all of this. That's why after I added it, it looks like a pink color, right? It was purple. And now if I give it enough of a flush, you'll see it. Okay. It's almost completely all pink, right? Yeah. Okay. There is a precipitate of the silver chloride at the bottom, but in the solution itself is your cobalt water complex, which is now pink. Okay, so for the second observation for test tube number 4. You should write down that it was purple, but now it is pink. And the reason for that is because you've removed your chloride minus because it forms AgCl and it shifts the reaction to the left. Okay. We're not going to do test tube number 5, so you can just skip test tube number 5. You can just cross off the box for test tube number 5. Okay. Really, this will end today's video. This is the end of the experiment for lab number 5. Hopefully you were able to write down your observations and your data for each of these 4 test tubes. For the post-lab assignment, there should be a worksheet in your lab manual that you have to fill out and upload on Canvas. Please upload the pre-lab and the data and observations as one assignment, and then your post-lab worksheet as another assignment. Okay? This concludes this video, Lab 5 on Le Chatelier's Principle.